Okay, I'm going to get this answer key from the very beginning here. We are asked to find this integral using 5 rectangles with left-hand endpoints. So the function's a little bit hidden now by my drawing, but it is a function. It passes the vertical line test. When you're going from 0 to 10 and you're breaking it into 5 rectangles, that's going to be a spacing of 2 units every rectangle. You find that very simply by just thinking about your starting and your ending point and dividing by how many rectangles, and that gives you your width of 2. So you need only to find the left-hand heights, the function at that left-hand point, and that I've done that now. You just use your best guess counting squares. I thought it was about 3 high, 4, 5.5, 6.5, 7. I add all those up. That gives me 26. I multiply 26 by 2. You could certainly multiply each one individually by 2 if you want to find each individual rectangle, but we know from our distributive property that that works mathematically. So I've got 52 square units. Anything from 48 to 56 is probably good. All right, moving along. This is really one just testing your ability to know what this all means. Think about that. If I gave you that problem at the beginning of the year, you'd have literally no clue. Now it's simply asking you to evaluate the area under this shape, which I tell you is a half circle, from 4 to 8. It's clearly a quarter of a circle. I'm telling you it's a circle. So you simply use pi r squared. 4 is the radius, and you're using 1/4 of that. So it's just simple math. Don't make that into a bigger problem than it is. Number 3, find the area under the curve defined by the x-axis and the function x squared minus 2x plus 1. This time with right-hand endpoints over the interval from 1 to 4. That's not totally clear, but that's number 1, 2, 3, and 4. So that's a domain of 3. So again, we can take 4 minus 1, get 3, divide by our 6 rectangles. That means the width of each rectangle is 1/2. So just like number 1 up above, you find the function values on the right-hand endpoint. So it starts at 1, but it's got a width of 1/2, so we start at 1.5. We find each of the corresponding f of x, the right-hand points. We add all those up, get 22.75, multiply by 1/2, and we get that. Just be warned on the test, I might have you also do it through integral, so I did this just for fun. I did it as an integral. You can see the work there as posted, and this is the exact area. It turns out to be 9. Why is this less? Well, because the right-hand endpoints overestimate by these little extra bits right there. Okay? For the second page now, there was a mistake in the original posting, so my apologies. I just was going too quickly. The key thing here is to take this radical x in the denominator and do sort of a reverse, find the common denominator when you add fractions. I'm going to separate these out, so I make this over the denominator minus the second part over the denominator. And when I separate them out, we get our simple exponential rules apply. I probably should have written this as x to the 1/2 over x to the 1/2. I think I'll change that before I post it. But at any rate, those cancel and become 1. So this is 3 minus 1/2, and so I've not written it as 2.5, but rather the fraction value. There's nothing wrong with going decimal, but this is just more traditional, I guess. So when I take the antiderivative of that, because I'm trying to find f of x, and I've been given the second derivative, so I go antiderivative, you have to write a little equation. I know that when I add 1 to 5/2, I'll get 7/2. So 7/2, when I bring it out front and multiply it by some mystery coefficient, is going to give me 2. So I can write this little equation here, multiply both sides by 2/7, and I get then 4/7 as my mystery coefficient. It's easier. The antiderivative of negative 20 is negative 20x. I do the same thing here for this one, and I get 8/63 when I solve my little equation. Nice thing is you can always check it. When you bring this out front, the 9 will cancel with the 63, the 8 will cancel with the 2, and you get 4/7. Then the antiderivative of negative 20x, that goes up to 2. 2 times a negative 10 will give me negative 20. Don't forget to add the c, and then the cx plus d. Okay? And final problems here. You're actually evaluating the integral. So you're just going to do the antiderivative, beginning and ending points. Same process, you're just going backwards. You don't have to add the plus c because this is what's called a definite integral, finding an actual number. So when you get the antiderivative, just remember your starting and ending points. You put in the top point first and you subtract the bottom point. In this case, zeros appear, and it is a very simple 136. Okay. Know your simple antiderivatives, but I'm going to let you guys use a table of integrals. So if you're not sure, you can just remember that the derivative of sine is the cosine. And so to reverse that, the derivative of the negative cosine gives you the positive sine. When you have your starting and ending points, you plug them in. This is the one that turns out to be 0. And then the cosine of 0 is 1. You can put that in your calculator if you're not sure. But minus a minus 1 gives you an area of 1. So when you've done those sine curves like you graphed last year, just remember that the area underneath that first quarter circle has a unit of 1. Then the last one of these integrals is e to the negative x. Do this because you know that the derivative of e to the x is e to the x. The derivative of e to the minus x will mean you bring a minus sign out front. So when we do the antiderivative, we just bring that minus sign out front first. So when we take this derivative, that will come out, and we've just got positive e to the negative x. From 0 to infinity, when you plug in a number to the negative infinity, that's going to go to 0. And when it goes way out here, it's 0. And then e to the 0 is 1. So we're subtracting a negative 1, so we get 1 again. All right? Then finally, be prepared to answer in your own words. What is a derivative? Well, it's that tangent line as the fixed point is approached by the moving point. An integral is an area as those rectangles get infinitely narrow and the inaccuracy disappears. And how are these related? Well, they're related through that use of infinity and limits, but they are in fact mathematically inverses of each other. Okay? Good luck.